When we're talking about the Web API pipeline and requests and responses and things we can do in that process to improve our applications and simplify the code we have to write, there's a couple of areas that nearly every Web API project has to deal with. And so what I want to look at are a couple of ways we can deal with these areas in ways that won't require us to do a lot of heavy lifting in the pipeline and write tons and tons of framework code. The first thing I want to talk about is improving CRUD responses. And for those of you who have never seen that acronym before, CRUD stands for Create, Read, Update, and Delete. It's an acronym we use in databases that refer to the basic database operations. The reason we like to improve these responses is because by default, the Web API always sends the same HTTP response code. The only time this is different is if some exception is thrown, in which case it sends a 500 server exception. But generally speaking, no matter what operation you're doing, whether you're adding, updating, or deleting, you always get the same response code back. Now, that's not necessarily a bad thing, but the problem is that some clients may use that response code to be able to make decisions as to whether the operation was truly successful or not. So if you're just sending back the same default response all the time, the client has no way to know that things either did go or didn't go the way that they figured. So one of the things you can do is to alter the HTTP response to include more accurate info. Now, this isn't just limited to improving database responses. This also comes into play when we talk about exception handling of any sort. What happens when an exception is thrown on the server is it's going to send back a 500 error. This tends to be very vague on the client. Everything that goes wrong is a 500 server error. In fact, you've probably seen this before just out and about on the internet. Or if you're an application developer, you have probably seen this error a lot while you're troubleshooting and debugging, and you've cursed it under your breath because it doesn't tell you anything about what really happened. It just basically says, hey, something went wrong on the server. But of course you knew that because whatever didn't work didn't work. What we can do is send an HTTP response exception, which will send more specific information to the client about what actually went wrong. So kind of like we can improve our CRUD responses to give the client more information about success or failure, we can also send the client more information to give them information about things that go wrong server side, so you can display a meaningful error message on the client, for example, or log it somehow on the client so they can call customer service or whatever you want them to do. The last thing you can do is you can actually use filters to assign HTTP responses to exceptions that are not normally going to be caught. Sometimes things just go wrong, and you don't have a specific HTTP response exception for those. So we can write filters that can trap errors that come up and create HTTP responses out of them. So all these things that we're going to do are ways of improving our HTTP responses to the client, giving them more information about what actually happened on the back end. And we can do that by using our pipeline objects without having to get serious into the way the pipeline is actually being processed. I want to take a look now at some code that illustrates some of the things that we were talking about in the slides. The issues of our CRUD operations and exceptions being thrown on the server side, but the client not really having a good idea of what happened. What I've got here is a books controller, and we've got 3 books in our data. And so it's going to be pretty easy for us to test. And this is really basic CRUD operations right here. We've got our gets, which are reads. We've got our posts, which are creates, puts, which are updates, and our deletes, which are the deletes. And so these are basic database operations. Now, these are things that you are going to be doing lots of when you write not just Web API code, but any code really. We interact with databases a lot, and these are the 4 main ways that we interact with them. So the code that I'm going to be showing you here is code that you can really reuse pretty much just as is in a lot of your own projects. What we're going to try to do is we're going to try to explain to the client in more detail what is happening here on the back end so that the client can deal with it if they choose to. For us, we can see really clearly what's going on the back end, but a client won't. And even if we write the client, we will appreciate being able to see better error messages so that we can troubleshoot more effectively. But you also have to understand that when you put your code into a service architecture like this, that you may have clients consuming them that you have no control over. And so if they just get back no response, or if they just get back a generic error response, or even if they get back a success when really technically it wasn't a success, they're just not going to know how to process that. And so we're going to help them out by sending better HTTP responses. So I'm going to come down here to get. So here we have a get method. It takes in an ID, and what it's going to do is go to our repository, find the book by the ID, and return it. And this works just fine. But what happens if we don't find the book? What happens if I put in an ID of 17? I only have 3 books. Well, there is no book at 17, and so what happens is the book isn't found. Well, we're not necessarily going to know this the way this is coded as it is. We're going to look for a book. That book is going to be null, and it's going to return that null to the client. It's just nothing. And what the client does with it at that point depends on how it was written. It might blow up. It might display some generic error. We don't know. But what we can do is we can more specifically tell the client what just happened. And so what I'm going to do is just add a pretty simple bit of code here. I'm going to say if the book is null, in other words, we didn't find one by that ID, I'm going to throw a new HTTP response exception. And I'm going to use the status code not found. This is the 404. Okay, if you've used your web browser and it gets a 404, this is where it says something like web page not found or whatever it is. We've all probably seen the 404 error. Well, here the requested resource isn't a web page, it's a book. And it's not just a book, it's a book with an ID that we don't have. And so just like you're requesting a web page from a server that doesn't have it, here you're requesting a book from a service that doesn't have it. And so we're going to send this back in our HTTP response. So when I build this and fire it up, and I look for book 1, okay, it's actually going to send me back a JSON response. And there's my JSON for book 1. Okay, so far so good. Now what happens if I ask for book 17? I get a 404 not found. Okay. Now because this is a web browser, which is not usually how we directly access the web API, it says the web page cannot be found because it assumes we're looking for a web page. We know we're not, but at least you can see that we did get that 404 back, that the resource can't be found. So what we want to do is, with most of our methods here, we want to help out the client when things don't go well. But we also want to help them out even when things go well. We don't just want to send success back all the time. The client may be assuming that something is getting done, and success may mean, hey, we didn't do it, but we didn't error out, so success. Well, from the client's perspective, that's not really successful. We need to tell them that the operation went the way that they literally intended. So, for example, here I've got a post method. This is what we use to add a new book. And right now, all it does is add the book. That's it. And we just send a default success back. Well, what we want to do is we want to send back an HTTP response that tells the client, we did add this new book, and here's its new ID, and here's the new resource where you can access it. So what I'm going to do is I'm going to come up here and change the return type to HTTP response message book. So we're actually going to construct a response message. This is not actually going to be void, and it's not actually going to be a JSON response of book data. We're actually going to send an HTTP response straight from here. It's not an exception. Everything went fine. But we are going to try to specify exactly what happened. Okay. Right now it's saying not everything returns a value because we got to construct this message. So here we go. I'm going to create a response. And it's going to be a new HTTP message, response message. I'm going to strongly type it to book. And what I'm going to do is in the response, I'm going to include the book object that we added, and I'm going to send the code created. So it knows this new resource was created. So it's not just, hey, your request came through, we heard you, thanks everyone. We're actually saying, no, we specifically created this new resource for you. Now, if we really want to go the extra mile and help the client out, then we also want to tell it the URL where it can access this new resource and add that to the headers of our response. Okay, so what I can do is get that URL. What I'm basically going to do here is I'm going to get our current URL and I'm going to add a new ID parameter to it. Let's see here. New ID equals book. This new book's ID. Okay, so I've taken our current URL and what I've done is I've replaced the ID parameter in the URL with this new ID. So now I've got the URL of the new book and I'm going to add that to my headers like this. Okay, here's the URL that was the original request. Here's the new URL of the new resource. So that's a lot of information to send back to my client, but really now the client is free to use this information however they want. They can actually redirect the person to the new resource because I sent them the URL for it. They can load in the ID of the new resource because I sent that back in with the response. And I sent them the code at the very minimum to show them that the created actually happened. So not only was the transaction successful, but we added the book just like you would expect. And now the client is free to use that however they want. So we really did them a favor by doing a little bit of extra work to send a much better HTTP response in our pipeline. So I come down here to put, there's nothing particularly special that we need to do here. All I did was throw a new HTTP response exception if the book wasn't found, much the same way as we did with the GET. Okay. If I wanted to, I could go in here and I could say, well, you know, if it was not changed, then I might throw a different code. And it depends on how much I want to do here, but this is pretty decent for put, just to tell it if I can't find what it's trying to edit. And then we come down here to delete. Okay, I just have books remove ID. Once again, all this is going to do is send back the default success message. Whether it was actually deleted or not, as long as no errors occurred, it's going to get a success message. So let me help out the client. Let me tell them more exactly what happened. I'm going to send them back an HTTP response message. Now, I'm not going to strongly type this. And the reason why is because we're deleting. The book doesn't exist anymore. So I can't send it back. It's gone. In fact, it would be very misleading for the client to get this book data back. So I'm not sending an HTTP response message of book because I'm not going to send it a book. I'm just sending it a plain response message. And I'm not going to send it a new URL or anything because we deleted it. All I'm going to do is say return new HTTP response message. Very simple here. HTTP response code. Whoop. Status code, rather. No content. That URL that they sent us no longer has content, and we will send that back to them. It's not an error. It's not saying I didn't find it. It's saying now this resource has no content. And that's its cue that that delete actually happened. So you can see by doing some relatively simple things here, between throwing HTTP response exceptions and actually creating our own response messages and loading those up with information, we can really give the client back a lot more useful feedback than just your basic response and failures. All right, so that sets us up pretty well, but we can do even more, especially when we're talking about these response exceptions. Exceptions are always tricky because, like I said, usually when you throw them from the server side, the client doesn't know that much about it. So when it comes to throwing exceptions, we may want to really load this up with information so that the client has a lot to go off of. And just to kind of show you what possibilities exist, I'm going to go back up here to our Find by ID. Now, you remember what we did just a second ago is if we can't find the ID, we're going to throw a response exception and we're just going to say the code is not found. And that's perfectly fine. There's nothing wrong with that at all. But if we wanted to do even more and we wanted to send even more specific information that the client could query, we can do that. We can absolutely load up this HTTP response exception and do various things with it. So what I'm going to do is I'm going to keep our same basic logic here. If the book is null, then I'm going to do something. And I'm still going to create this message, but what I'm going to do instead of just throwing it the way it is I'm going to put it in a variable, and I'm going to add some properties to it. Okay, so I've got this response object here, and what I'm going to do is I'm going to add, let's do this. Instead of a response exception, let's make this a full-fledged message. And what I'm going to do is I'm going to send content make that equal to new string content. And I'm going to create my own descriptive error message that's going to go with the response. So I'm going to say no book has an ID of, and then we will just plug in the book's ID here. Okay. And I'm going to add a reason phrase, just a simple string. The book ID was not found in our data. Okay. Now that I've got this all set up, I'm going to come down here, and here's where I'm going to throw my new exception. Okay, so what I've done is I've taken that very basic HTTP response exception, and instead of just setting a code, I've populated it with some message data here. So we still get the status code, not found, but at the same time, now the content specifies that the notebook has an ID of whatever, and then it says book ID was not found in our data. So once again, the client could read this and stream these directly into error messages that it displays, or write these to a log so that it knows what actually happened. You're doing your clients a real favor by doing this. It does take a little bit longer, and maybe not all of this is the clearest code you've ever written in your life, but you're really helping out your clients in the long run by putting in all this information into our exceptions. Okay, so we've looked at HTTP response messages and we've looked at response exceptions, and just now we've seen how you can even combine them together to produce really full-fledged exceptions that you send to the client. So what about exceptions for which there is not a specific HTTP response exception? Let's say the client wants to search for books and our database goes down, or we're using some kind of ORM and the SQL that the ORM generates is not good, and so there's a SQL error. So the operation didn't succeed, but it wasn't some logic problem like we've got up here. It was some actual technical failure. It's an exception that just doesn't translate directly into an HTTP response exception. Is there a way we can catch those and then do things with them? And we absolutely can. These are called exception filters. This is kind of a step up the food chain from what we've been doing, because now we're actually going to add objects to the pipeline. They're not full-fledged custom handlers, but they are going to be filters that sit there and listen for exceptions and will generate responses based on those exceptions. So what I'm going to do, doesn't really matter where you put this. I'm going to go ahead and put it in controllers just for convenience sake. I'm going to add a new item. It's just going to be a class. And I'm going to call this, let's handle methods that throw a not implemented exception. Now I'm doing this just for convenience. Probably your code doesn't have a lot of these. I could just as easily make a SQL exception handler or an array out of bounds exception handler, any exception that I wanted to deal with. I could even make a handler just for the base exception if I wanted to handle all exceptions the exact same way. But just for demonstration purposes, we're going to handle the not implemented exception. So if you've not seen that exception before, that gets thrown when somebody has a method that has no code in it, and so it says it hasn't been implemented and it throws a not implemented exception. Most of the time when you use Visual Studio to stub out code or ReSharper or something that generates code for you, it will stub methods out with not implemented exceptions. And what you're supposed to do is go through and implement those. That doesn't always happen. Other times you may be implementing an interface or overriding a base class and you just don't need one of the methods. So you just put a not implemented exception in there because you're not going to use it, you're never going to call it, and then sometimes somebody comes along behind you and they call it and that exception gets thrown. So what I'm going to do is I am going to inherit from the exception filter attribute. And this is going to be found in web HTTP filters. Add that to my using statements there. And really, there's only one thing that I need to override. Notice there's several different things I can override here, but I just need to override what happens when this exception fires, right? And it's going to pass me the action executed context. Okay, so that controller is going to fire. And what I can do is I can say if the exception let me get the right variable name here for the context. If the context exception is a not implemented exception, then I want the context response. Make sure I got this right here. So I want my to be a new HTTP response message where I can return a status code. And that's going to come from system.net. All right. Okay, so what I've done is I've basically trapped every not implemented exception that's ever going to come through the pipeline, and I handled it in this way. Now, I don't know that I would want to go through all this trouble just to do this. Probably what I want to do is if I'm going to write a filter, I'm going to want to log this exception, maybe even send email, maybe put it into a database. The more serious the exception, the more steps I want to put in here. But this at least shows you how you can write code to generate exceptions and handle them gracefully that happen server-side. So I could put my logging in here, everything that I would normally put in here besides just sending back the code. So once I've got that written, then I need to actually wire that up into the application, and it's relatively easy to do. I'm going to come over here to my global.asax. And what I want to do is add this to the HTTP configuration. Now, there's all kinds of different ways to break this out. I'm going to try to do it in a relatively straightforward way. I'm going to try to do it in one line. Let's see. Let's do it down here. Let's make it the last thing easier to see. And I'm going to say global configuration. configuration, filters, add, new, and then I'm going to not implemented exception handler. And that's going to come from my controller's namespace. Probably what I would want to do is put this class in a file called utilities or something so that I could have kind of all my infrastructure stuff right there. Not implemented. There we go. All right, so now we're good. And so now this is wired up into the pipeline, and I'm all ready to go. Now, normally what we do is we isolate this into its own little subroutine, like a configuration method, because we may add a lot of handlers and filters and things to the pipeline, and it's going to get pretty ugly to keep copying and pasting this line over and over. So we might have a helper method here where we pass it the global configuration, and we just do all of our work there. But at least this shows you how we can wire up that filter to the pipeline, and now that filter will take care of all our not implemented exception handlers.